Here we're solving for the x-intercepts of a quadratic, y equals x squared minus 49. Now if it was a calculator active question, you could just type that in and see where it crosses the x-axis. But here we're going to do it algebraically, so you do it without a calculator. And you're starting by setting this y equal to 0, because the x-intercept is where it crosses the x-axis, and every point on the x-axis is a y value of 0. So 0 equals x squared minus 49. Next, we're going to factor that right side. So we have a difference of squares here. It's a perfect square minus perfect square, so we know we can factor that. X minus 7 times the quantity x plus 7. And I just did the square root of x squared is x, put that in the front, and the square root of 49 is 7. One of them is minus that 7, one of them is plus that 7. The reason this works is because you get a negative 7x and a positive 7x that cancel out. That's why there's no x term or y term. Now we can solve for when this is equivalent to 0. Basically, if we have a factor times a factor equals 0, one of those factors has to be 0. The only way to multiply two numbers and get 0 is if one of the numbers is 0. So x minus 7 is 0 when x equals 7, and x plus 7 is 0 when x equals negative 7. So those are your two x-intercepts. Sometimes you'll hear them called roots or solutions or zeros. And if you graphed it, one of them is 7 to the left of the y-axis, one of them is 7 to the right. In this case, our x squared term is positive, or you could say it's a positive a value. That means that it's going to make a smiley face. So if you drew it, it would look like that. It passes through. The vertex is actually below the x-axis in this case, but it looks something like that. And again, these are your two answers.